In this figure, two blocks of masses, let me write down the masses 2 kilograms and mass of 3 kilograms are connected by a light string that passes over a frictionless pulley of a moment of inertia, let's mark the moment of inertia, of 0.004 kilograms times meters squared, and a radius of 5 centimeters. So let's just convert this to meters. 0.5 centimeters. And then 0.05 centimeters, sorry. And then the coefficient of friction for the tabletop is 0.300. And then the blocks are released from rest. Using energy methods, find the speed of the upper block just as it has moved 0.600 meters. So that's the distance that we're working with. And we're basically being asked to find the velocity of the upper block, this one, after it gets pulled down. So now that we have these values, we can start trying to see the mechanical energy of this system. So the mechanical energy of the system is going to be equal to the negative friction, the friction force, times the change in static friction. So this is going to be the mechanical energy of our second object minus the mechanical energy of our first object in the pulley system. So the first thing we can do is, let me make some space because we do have a big equation to work with in this case. We're going to multiply the mass of our first object times gravity times the distance that we're given minus the mass of our second object times gravity times the distance that we're given again. And this is going to be equal to half of the mass of our second object times the velocity squared. And then that's going to be plus half the mass of our first object times the velocity squared again. And then finally it's going to be plus half of the inertia times the angular velocity squared. So let's just plug in the values that we do know. We know that the first mass is 2, and then gravity is going to be 9.8 in this case. We know that the distance is 0.6. And now for the other object, we know that the mass is 3. 9.8 again, 0.6. And now we equal that to half of 3 times v squared, since we don't know the velocity yet, plus half of 2 v squared plus half of the moment of inertia, which we know is 0.004. And then the angular velocity is, we don't know it yet in this point, and we're actually going to take it out of the equation in this case, and then we're just going to convert it to V2. And then after we calculate the majority of the values, we're left with 11.76 minus 17.64 is equal to 1.5 the velocity squared plus the velocity squared again plus a very, very small value of 0.00005. We can actually completely discount this value since it's so small. And we're going to be left over here with negative 5.88 equal to 2.5 v squared. And now we're going to divide these values, and we don't want a negative value in this case since we know that the acceleration, the velocity of this object is actually going to be positive in this case. Both the acceleration and the velocity are going to be positive because it's going to be moving in the right direction when it gets pulled by the 2 kilogram object. So now we can divide both sides by 2.5, and that's going to give us the velocity squared is equal to 2.35. And now we square root this value to get the velocity isolated. Our final answer is a velocity of around 1.53 meters per second. So that's our final answer, 1.53 meters per second. And among these answer choices, the one that's closest to this value is 1.40 meters per second, option C.